Hello and welcome to a revision video looking at the balancing method for solving equations. So just as a brief intro here, we have equations when we know that two things are equal to one another. So even 3 plus 2 equals 5, that's an equation. It's got two things which are equal to each other. 3 plus 2 is exactly the same thing as 5. And we know they're equal because it has an equal sign. That's there to show that two things are equal. Now, if you're asked a question where you need to solve the equation, there's going to be something unknown. And to solve it, we'll need to work out the value the unknown is. So, for example, we might have 3a plus 7 equals 10. In this situation, we've got an equation because we've got an equal sign, but it's one we can solve. We have this unknown value of a. Now, as you can see from the title, this is the balancing method for solving equations. So, to help us with seeing this, I've got a set of scales here on the board, and I've got two things. I've got x's, which will stand for our unknowns, and I've got weights to show that two things are equal. So, the first thing we're going to do is we're going to think about what happens if I've got an equation such as x plus 3 and so we've got 3 weights there, equals 8. So our equation will be x plus 3 equals 8. So you can see here, on one side of my scales, I've got my x plus 3. On the other side, I've got my 8. So written out, this would be x plus 3 equals 8. Now you can see here I've got two lines that run down either side of the equal sign. This acts in the same way as the centre pole does on this set of scales. It acts as that balancing point. Now if I'm going to keep this balanced, whatever I do to one side of my equation, I have to do to the other. So for example, if I was to take one weight off the left hand side to keep it balanced, I'd have to take a weight off the right hand side. Now we're trying to work out what x is, how heavy x is in this situation. And to begin with, I've got x and 3 extra weights. So what I want to do is I want to take off those 3 weights. So I can do that, just lift them, take them off. And on my equation, I've taken away 3. Now if I've done that on one side, I need to do it to the other side as well. So I take off my 3. You can see I've taken the same amount off both sides, and now my scales are still balanced. So I took 3 off one side, and I take 3 off the other side. This is why it's called the balancing method, because we have to keep things balanced. Now, to solve this, and to show this on my scale, my grid at the top here, I add x, I added 3, I took away 3. All I'm going to be left with is just x. That plus 3 minus 3, they've left me with no extra weights. As we can see on the diagram, there's no extra weights attached to that x. On the right hand side, over here, I had 8 weights, I took 3 off, and I've got 5 left. So I've worked out that the weight of x is equivalent to 5 of my weights. So my solution to this equation is that x equals 5. I can then go back and check that. If x equals 5, I can say, well, I'd have 5 plus 3. And yeah, that does give me 8. So that works. I can tick it to show it. Now, this is an example of a one-step equation. There was only one thing that we had to do. We had to get rid of the 3. We'll see another example of a one-step equation here. So we've got, in this one, instead of just one lot of x and something added to it, I've got 2 lots of x. And this time, I'm going to have 1, 2, 3, 6 things. So the equation that I'm solving, I've got 2x on the left-hand side, and on the right-hand side, I've got 6 weights. And I'm asking how many weights is 1x equivalent to? Well, the thing is here, we've got different things on both sides of my balance. So I can't just say, oh, I'll take x off one side and I'll take it off the other. because it's not there on the right hand side. What I have to do is say, okay, well, I'm going to take off, I'll split this into two piles. I've got two piles of weights on the left hand side, that are, on the right hand side, that are the same. They've got 3 weights in each. And I've got split those two x's, two different piles, 1 x in each. So what I'm then going to say, well, if I take off, divide that in 2, and divide the right hand side by 2, I'm left with it equally balanced. I've taken off half of each side. So I divided my left side by 2, and I'll divide my right side by 2 as well. On the left hand side, if I've got 2 lots of x and I divide it by 2, I've just got x left over. And if I had 6 to begin with and I divide that by 2, I've got 3 left over. And we can see that on our scales. We've kept them balanced. We took off half of what was on each side. We split it into 2 equal bits. And I've got x left on the left hand side, and I've got 3 remaining on the right hand side. So that's another one-step equation. And you can see when we're solving these, we're doing the inverse. For the previous question, we added 3 originally. There was 3 extra, so we had to take them off. Here, there were 2 lots of x, so we did the opposite of multiplying by 2 and divided by 2. We're now going to look at two-step equations. So this one, we'll have, on the left-hand side, we'll have our 2 lots of x, and we'll have, let's just set this to work properly, we'll have 3 extra weights. And on the right hand side, we're going to have 1, 2, 3, and duplicate that. Duplicate that. We've got a total then, to balance that, of 11 weights. So my equation here, the left hand side, is 2x plus 3. The right hand side, I've got 11 weights. So we know that 2x plus 3 equals 11. Now we're going to combine what we looked at with our other 2 equations. The first thing that we need to do is get rid of 3 weights, because we were able to deal with this when we had them in. We had just x's on one side, because that's what we're trying to do. We're trying to be left with just an x on one side. So we took 3 weights off both sides. So on our equation, we take away 3. And again, we're doing it to both sides because we're keeping it balanced. 2x, if we add 3 and then take 3 away, all we're left with 2x is with 2x. And we can see that on our scales. On the right-hand side, we had 11. We took away 3. We were left with 8, which we can see there. We've got 8 weights left. They're still equal. We keep that equal sign running down the middle. Now, the next thing we do is, well, we've got 2 x's, so we want to split that into 2 piles. That right-hand side, if we split that into 2 piles, we divide it into 2, and we'll take them off. We'll take half of it off that side. We'll take half of it off that side. So in solving our equation, we write that as we've divided by 2. Now that gives us x equals 4. And we can see that here. We've got x on its own on the left. We've got 4 weights on the right, giving us x equals 4. And we can put that back in. We can say, okay, so if x is 4, I can do 2 times 4 and add 3. Well, that's going to be 8 add 3. And yes, that does equal 11. Now we're going to do one more example of this two-step method. Still focusing on ones that we can see using our diagram, but this time I'm going to have 3 x's. So I've got 3 x's and 1 extra weight on the left. And on the right hand side, I've got 1, 2, let's duplicate that. We'll go like, there we go. And we'll stick 1 extra one on the top. So our equation here, the left hand side is 3x plus 1. Then we've got the middle, so it balances, so it's equal. And the right hand side is 7. So the first step is we've got to take off 1 from each side. That will leave us just with x's. So that's on our equation, we take off one from the left side, so we took one off from the right side to keep it balanced, leaving us with 3x equals 6. And our next step, well, before we had 2x's, so we had to create 2 piles. This time we've got 3x's, so we're going to have to divide it into 3 piles. So if we're dividing it into 3 piles, we'll have, well, we had 6, so if we do 6 divided by 3, that means each pile has to have 2 in. So we do 6 and we divide by 3. So one pile for x is going to need 2 weights in it, which makes sense. 3x divided by 3. It was times by 3 originally, so we divide by 3. That just leaves us with x. 6 divided by 3 will leave us with 2. And we can see that if we take off one pile, one of those 3 piles, 1x, and then to take off another one of those 3 piles, and another x, we're just left with x equals 2. Now this goes through basic 1-step and 2-step equations. I'll do another video shortly that will go through extending this to ones where it becomes a little more complicated, looking particularly at equations where we've got unknowns on both sides and what to do when maybe we've got something taken away. Thank you for watching the video, and I hope that it's helped you with your equations work.